Hello and welcome to PMCD MATHS Teaching. My name is Paul McDonough, and this session is covering solving linear equations, which is fraught with all sorts of controversial arguments that I've had over the years about how to go about this. But this is my take, and you can take it or leave it. But this is what I've found to be effective over the time. As usual, we're looking at, solving linear equations here. We're looking at solving equations with unknowns on one side of the equation and on both sides, and it's over a number of lessons usually. Rationale, I'm just going to put up now. Okay, I think we're all as teachers, quite influenced by how we were taught this. And, I'd say my first encounter of being taught how to solve linear equations, was, I could do it, but it was pretty poor. I mean, this thing I'm saying here, move the 5 over, it becomes a minus. It was almost like magic, It was almost as if the teacher would say, you move this 5 over to the right-hand side, and as it gets over the equal sign, it becomes a +5. As it passes over the equal sign, it magically becomes a -5. And that was my understanding. I mean, right up till I left school, I think. I mean, I could do the equations. Obviously, there's big problems with that in terms of understanding why. Why? It just felt like magic to me. And, only those people that know have got the magic can actually do the maths. And we know that's not true. I know that's not true. Now, there's a reason for everything. And as I said here, rooting it in a concrete example is really important. Now, I have not shown this here, but in the past, I've used images. I've had images of seesaws. I've even got students up there, giving them all a value. Might be saying that they all have the same value in terms of points or something like that. And, shown physically how we can keep a balanced seesaw or weighing scales. And I think there's lots of things on the internet you can find to show that as well. But to me, the balance method, is probably the most effective. And if you maintain this helps with rules of manipulating equations, rearranging formulae. The sooner that I think students get that idea that you can do anything to both sides of an equation or a formula, you can carry out any operation as long as you do it to both sides. Sometimes it's going to make it easier. It's going to lead to a solution quicker. Sometimes it's not. And those go into A level. We talk about trigonometric identities, which is not quite the same thing, is it? Because identities we wouldn't mix the sides up. So that's a bad example. But anyway, so yeah, it does help us out. So okay, so let's move on then. What do I start with here? Well, let's look at the sequence of teaching. Again, I'm saying sequence of teaching. I'm not saying it has to be done in this order. I'm just saying it's more prerequisite knowledge in the stage here. And this one, you can see there's no, I think by the time we get to solving linear equations, I like students to be able to convert between proper and improper fractions, because I don't want to limit them just to integer solutions. Even very, very quickly, I want them to get into comfortable with fractions, and then using the short and long division methods, some people call it the same thing, to get a decimal solution to what they've got, and give them that confidence that they can do that. And again, you're consistently practicing these skills. Then it's not like I did fractions in September or of year 7, and it's year 9 now. I can't remember what I'm doing. If you're doing it regularly, this becomes embedded. It becomes part of their language. And obviously, the benefits of this are when you get to changing the subjects of the formula, we're going to use the balance method there again. A little bit more abstract, but there's enough, I think, from solving equations for them to be able to move on into that. So, I'm not really showing anything here that hasn't been shown in textbooks or anything before. It's perhaps just, little tweaks of perhaps what I say or do or question as I go along here. So to start off with, forming an equation, a lot of students will be able to do that and they'll be able to explain it, and they would be using the inverse method. And some of them, when they start equations, they don't even see the value of using a balanced method, okay, with this example here. But you can do this in both both ideas. And I usually show them how this can form an equation. And again, forming equations, you know, I think we can, I wouldn't do, you know, as an extension task, that might be something I would do for a high ability set once they've got the hang of this. But then I think for the majority of students, that would be a separate lesson and then bolt this skill on at the end of it. Okay, so I could have put that in the sequence of teaching, couldn't I, after changing subject to formula? I mean, be ready then to form and solve equations, which, you know, we know is quite a difficult skill. Okay, so what have we got here? She multiplies a number by 3. She thinks of a number, and this is the whole idea about calling it x here. So what we're going to do is, we're calling it x, you know, she multiplies by 3 and then adds 6. So what you're going to get then is 3x plus 6 equals 28. And then, you know, you're going to get, oh, why do we have to do that? I know what the answer is, you know, and well, I'm just going to reverse it, you know, and that's the inverse method, isn't it? You know, you times by 3, you add 6, and out comes 28. Okay, this one to x, so if we go backwards, 28. Missed the 6 there, didn't I? Inverse, nice one to introduce that language, inverse, mathematical opposite, divide by 3. And, you know, for weaker students with solving linear equations, they may just want to get comfortable with this. You may want to keep them with this, but, you know, don't limit what you think. Always throw the balance in, see if they can deal with that, I think. 22 and divide by 3. Actually, this was one, actually, I didn't realise this is one where I throw it, so they couldn't actually do it straight away, but they get their calculators out, some of them, you know, and they'll get, what's that? So 22 divided by 3 gives us 7, doesn't it? 7 and 1/3, I think. So 7.3 recurring. Have I done that right? Yeah, 7 1/3. So they'll write this, but they don't often know what it means. And what we want by the end of this is them to go, so yeah, well, 7 1/3, that's 7 1/3, or that's you know, 22 over 3. Okay, and they understand that. Again, not my pet hate here. People who 7.3 recurring then suddenly go, oh yeah, that's 7.3. No. Okay, so then show them how they do it with the balance. Now, the only sort of stipulation in here, you know, I've done this with my department as well, is how we lay this out. And I've done this lots of ways over the years with arrows and all sorts. But what we found is students really like this method where, let's just do this one here. I know you all know how to do balance method, but I'm just looking at how we'd lay this out. Very important, I think, layout. It does get, from my observations I've seen of, particularly of new teachers, because they're new to it and it's still learning, obviously, so that's not criticism. But it's like enough to get them to understand what to do, and then secondary is, oh, how do they lay it out? How does it look? We're not talking about neatness here. We're talking about mathematical communication. Neatness, and you know, is another thing altogether. We have to be able to read it, but mathematical communication is important. So firstly, working vertically down and not across the page, which students like to do. They like to work from left to right. Reason for that, obviously, you know, you're going to run out of space very quickly if you move left to right. And even more important than that, if there's an error, it's harder to trace an error going horizontally than it is going vertically down. So what we do, put these lines down here, and the whole point is we're going to solve within those lines. We're going to show what operations outside the lines. So what would I normally say here? I'll say we're trying to find x, the value of 1x. Okay, that's what we're trying to do. We're solving an equation. We're trying to find the value of x, which will make this true, that 3 times that number plus 6 will give me a value of 28. Now I'll say that again, because again, we all want to rush into solving equations. We're often very easy to just miss that what's going on here. It's a little problem, it's a little puzzle like this one here, trying to find the value of x, and when we multiply it by 3 and add 6, it will give us the answer 28. Okay, so what do we want to do first? Well, I'm looking at that left-hand side of the equation. So again, more language here, left-hand side, right-hand side of the equal sign. So they can start using this language as well. I want to get x on its own, 1x on its own. What's stopping it on the left-hand side? Well, the plus 6 is, and the 3. And what's that 3 doing to the x? I mean, These questions have to repeatedly be done until they get the idea. Three, some of them won't know. Some of them won't know. So, you know, 3 multiplying by 3 and adding 6. Now, so they say, okay, I want to get rid of 3. Okay, what are we going to do? Divide by 3. Okay, well, let's do that then. Let's do that. Divide by 3. And we know that that's going to give us, you know, we have to divide everything by 3, and we get this horrible 28 over 3 on the right-hand side. So rather than saying no, let's go with it and show them, well, do you want to carry on this way? What's the other option? We can subtract the 6. Okay, let's subtract the 6. Subtracting the 6, I'm putting that outside on both sides. So I'm showing that I'm doing it to both sides here. Equal signs in a line. And we get 3x. Here, we've taken away that 6. Okay, and I didn't mention that. What would make 6 disappear, wouldn't it? A plus 6, if we took away 6, that would make it 0. Well, I must take away 6 from this side, which gives me 22. Now, some people put that little -6 on here. I think that confuses things. I think having it outside here just allows us to do the operations in there. Okay, what's stopping x being on its own now? So I keep repeating this question. 3, what's the 3 doing to the x? It's multiplying the x. So how can I make that 3 become 1? You know, they have to understand, to make something become 1, you divide it by itself. So there's 2 ways of saying this. Sometimes I've said, you know, times by 3. If you divide by 3, that'll get rid of that times by 3 and leave us with x. It's a little bit murky, that one. Or you could say, yeah, I want to make a 1x. I want to have a 1x. I won't even write it here. I want a 1x. I'll write a 1 in there. I don't mind. What do I do to that 3 to make it become a 1? Subtract 2, yeah. Okay. If I take away 2, I'll get 3x minus 2, don't I? So that's not actually going to work. I'll take away 2x, then I'd have to take away 2x from this side, which then confuses the equation even more. You can do it, but it's not going to get us to the root of the equation that efficiently. So divide by 3, and the key is x is being times by 3, so we're going to divide both sides by 3. So we have 1x on this side. Let's write it down. Divide by 3 and divide by 3. And this is, again, important. How do we write divide by 3? We're going to go straight into writing it as a fraction. 22 over 3. Okay, divide by 3. And this is where that thing about knowing about converting between proper and improper fractions is important, I think. 22 over 3. You'd expect then, okay, what is that? I mean, that's not wrong as an answer. And actually, you know, to have a little secret in an exam, most of the time, that would be accepted as an answer as well. The students, you might not even know what that means. So that conversion is going to be important. So 7 1/3. And then we could also even go to, you know, okay, well, that is a decimal answer. Yeah, 22 divided by 3. Okay, so we get that 7.3 recurring. And I think it's, you know, it's tempting as it is to move on and try and get them to do hundreds of these straight away. Get them to do a few with the fraction decimal gives them real confidence that they're working with the whole, you know, where the whole range of how numbers are created. Fractions, decimals. Obviously, we're not using percentages here, but the fractions and decimals definitely. Okay, so I'm not going to add much more to this. I mean, pretty much all of this now, of these ones I look at here, okay, got some different questions. Here they can do this. You'll notice this question selection is really, really important. Look at this one here. Okay, that will throw them. Yeah, we're trying to knock them out of it, not allow them to slip into robotic patterns where their brain goes into neutral and their hands are working, but they're not really thinking about what they're doing. So that's a good one, I think. This one here, you know, what does that mean? So, you know, starting to stretch me a little bit here, there. And sorry, a little key for new teachers here. I mean, I always, when I create my my flip charts, and this is Promethean that I'm using here, I'll always, beforehand, I'll prep the question numbers there. So I'm not having to look in a book. It's there. I'm going to bring those up straight away. You know, even anything I need to remember as well, I'll stick on the slide. You know, I want to spend 10 minutes on this. You know, there might be a key word. There might be something that I think I'll forget if I don't write it up there. So it's quite a good thing to have there. So that's unknowns on one side. And, you know, you can bring in brackets, the fractions. There's all sorts of things you can do with this. Unknowns on both sides of the equation. Same idea here. Okay. Now, again, we'll go into this one first, actually. I think I've moved on from this here. So let's have a look. This sort of equation here. You see, I've got some robotic steps down there, so you might criticise me for that. But I think that there's an element of them having somewhere to start with this. We're still using the balance method here. Unknowns on both sides. What does this throw up? What misconceptions? Well, we're still going to do the. We're still going to put the bars down the side. I'm still going to put the equals in line. The truth is, you can do anything. You know, you'll find that some people prefer to deal with the numbers, the constants. The reason I don't do that is because once you've eliminated x from both sides, and you see I've used the word eliminate, not take it away, because that implies subtraction. Okay, it's because the next line will convert it into, well, I've given these grades, haven't I? I think I called it a grade 4 question, the other one. Might be a bit too high. But anyway, what I'm saying is it converts it into an easier question just by doing that step. Okay, the least amount of x from both sides, the least amount of x. So I say, what's the least amount of x? It's 3x. I'm going to take away 3x. It's a plus 3x. I'm going to subtract 3x from both sides. Okay, lots of little things can come out of problems here. You can have a lot of stick, you know, it's quite common to have a lot of sticking problems here. So take your time. Take the 3x, that's a 5. I take away 3x from 9x, I get 6x. And the minus 19 is unaffected. And this is worth discussing as well. Minus 19, and if you know about gathering like terms, you can refer back to that. You know, we take away 3x from 19, from negative 19, it's not going to be affected, is it? Because it's not an x term. You can only take x terms from x terms. You can only add and subtract numbers to numbers or constants. Okay. Okay, just want to pause there for a second. I know it sounds robotic here. You could also, you know, if somebody wants to do something different, go with them. Go with them. Say they want to take away the 9x from both sides, or they want to add the 19. Go with them. If they want to do that, and show them where it leads to, rather than say, no, 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 don't do that. So if we said, oh, I take away 9x from both sides, let's just start down here. We take away 9x from both sides. What happens here is you get a negative 6x plus 5 equals negative 19. Now, I can guarantee most students are not going to like the look of that. And you can deal with it with confidence, but, you know, when you've got confidence, sorry, but initially, I think, say, okay, what would you rather deal with? This one up here or this one here? Okay. The only one I could sort of say is acceptable is if people wanted to deal with numbers, you know, they want to add the 19 straight away. But as I've said, the reason I don't do the add 19 is because now this is pretty much the same question. If we go back to this, it's pretty much the same question as these ones we were doing, what I would call an easier level, what I've called grade 3 there. Okay. So when I say, I'll say to them, I mean, you know, whether this is accurate or not, it doesn't really matter. I say, oh, it's a grade 5 question. By doing that one little step, you've changed it to grade 3 question. Bang, you're going to get full marks. Do you know what you're doing? You know, and the whole thing about, oh, why do we do equations? You say, well, that's coming up. We're going to show you. You're going to make your own equations and solve them soon for, you know, basic problems to start off with. But this is the basis of how lots of problems are solved in real life. Okay. And I always use the FIFA PlayStation reference. You know, any sort of computer program is going to require some sort of equations for pixels to be meeting each other on a screen, or CGI for films. So, you know, luckily technology provides us a wealth of examples to say why we do this. But also, you know, it's just satisfying. It feels great when you get the right answer. Right, one thing I haven't mentioned here then, let's just finish off this one actually, and it's important here because this does get missed off, and you know, I've nearly missed it off. Add 19 to both sides on this one, so 6x is 24, add 19 over here. Divide by 6 both sides, the x is 4. What have we actually found out? That's the question. A lot of us will then get, right, what's the next question? Let's go. What have we actually found out? X is equal to 4, okay? So what we're saying, well, let's try it. We've done a bit of substitution before. So 3 times, if we've got that's 3 times 4 plus 5. And this one here would be 9 times 4 minus 19. So I'm just going to show the answers to these up here. What do we get? 12 plus 5 is 17. 9 times 4 is 36 minus 19 is 17. What have we shown? We have shown a value of x which has made the left-hand expression have the same value as the right-hand expression. Okay, simple way to explain this, we could say is there's two people in the class. You could say pupil 1 multiplied their number by 9 and subtracted 19. Pupil 2 multiplied their number by 3 and added 5, and they both got the same answer. What was the number that they multiplied? Okay, so they don't get the same answer, they also multiplied the same number. So, quite a nice question there. Okay, so I do, once I've done that, I tend to stick with this then, this eliminating the smallest amount of x. And again, there's ranges of examples, you can see. I'm a fan of hundreds and hundreds, but, I'll pick a selection of questions from there. And, fluency, I think with this, fluency is really, really important. And, the confidence with this, if you just do 2 or 3 questions, it's not going to be enough to embed that understanding. Negative x's here, how do we do that? Well, we're getting rid of the least amount of x, so that comes in again. So we're getting rid of a negative 2x, we're going to have to add 2x to both sides. So it's important to do that. And that's where that whole thing is we're eliminating the smallest amount of x, we're not taking away the smallest amount of x. Okay, and I've made mistakes saying that before, but I correct myself now. A range of examples again, moving on, and you can go on to higher level with fractions as well, if you wish. Right, so extension, you can use questions with forming equations. I'm going to be doing another video on that anyway, which you could link onto this. Example space is a good idea with mini whiteboards. If you've not read up about this, can you, as a question, can they make their own examples? And that's different to writing questions, because you might say, okay, can you write equations got an answer where x is equal to 3? Okay, so they might say, it's just a clean page to show you. They might say, oh yeah, x plus 1 equals 4. Okay, so what you don't that's not good enough, is it? So okay, and another. Or you might find somebody who's done x over 5 plus what's it, 3/5, isn't it? Okay, so you might say, I like that one. So you're trying to encourage them to come with something more adventurous. This is a great sort of plenary activity, or you might just throw it in there at the start of a lesson. It's this whole idea that they can make their own. It's not only textbooks and teachers who can come up with this; they can come up with their own, and we can get more complicated with this as well. So encourage them to be more creative with that. That's a good idea. There's a whole, if you look this up on example, pupils example spaces, it's quite a nice, there's lots of range of questions with these sorts of ways of doing things, and it's a good way for them to improve their confidence and their knowledge. I'm not going to talk too much about that because they could talk for hours about it. And, obviously where this moves on to is that we're looking at changing the subject of a formula. So when we get to change the subject, we've established this really, really clearly and firmly for them, and they've got, they are green. If they really are solid on this, it's going to make that step into changing subject to the formula easy. And I like to do that pretty soon after, maybe not directly after, give me a bit of rest of algebra, but directly, pretty soon after doing equations, so that you can link those things up, and they feel confident with that. Okay, so I'm going to leave it there. And I hope you found something interesting in there, or something useful for yourself there. And I will see you next time. Okay, bye.